Hello everyone and welcome back to my channel. Today I have a very interesting video for you where we'll be doing a small project on DevOps. It's a very small project, so essentially what we will be doing is we will be Dockerizing a Spring Boot application. So we'll be basically using three tools here. We'll use the Spring Boot for the application. We'll use Maven to build our packages, and then we'll use Docker to create the image and then run that application as a container. So it's a very small application. So very limited number of tools that we are using, but this is going to be my first project that I'm uploading to my channel, and I'll be spending more time on uploading many more projects related to DevOps and AWS. Once again, before I start off with the session, please don't forget to hit that subscribe button, and if you find this video helpful, please share it with your circle, and please don't forget to hit that like button as well. So let's get started with this. So the first thing is, what are we going to do? All right, so what we are going to do here is we're going to generate a small sample Spring Boot application. So we'll head over to the Spring Boot and we'll generate a sample application. Then you will be creating a sample image, a Docker image for this Spring Boot application that we have created. And then using this Docker image, we'll be running this container, which will start the application for us, and then we'll validate the application by accessing this container in our browser. So we'll generate an application, we'll create a custom image for that application, we'll run that as a container using Docker. So Spring Boot for the application, Docker for creating the container, and then we'll also have Maven in between, which will help us to create the package. So what are the tools that we will be using? So we'll be using the Spring Boot, which is an open source Java-based framework, which can be used for developing standalone production grade Spring-based applications with very minimal effort. Then we'll also use Maven, which is an open source build tool. So we can use this to create packages, to compile our code and create deployable packages. So as a build automation tool, this basically automates the source code compilation, dependency management, and also assembles your binary codes into packages and also executes the test scripts. And then finally, we have our Docker. So Docker is what we will be using to create our custom images and then run that image as a container. So this Docker, it's a software platform which allows us to build, test, and deploy our applications quickly. So using Docker, we can create packages, which is nothing but your standardized units, and we can call them as your containers. And these containers will essentially contain everything needed for the software to run. So it will contain your libraries, your system tools, your code, your runtime, basically everything needed for your application to run. So this is essentially what we will be using. Now, before we start generating our sample application, we will also need a machine. So in our case, we'll be using an EC2 instance where we will be running our application, and the tools as well. So let me go ahead and launch an EC2 instance over here. So let's call this as Spring Web App. And we'll be using an Ubuntu AMI. I'll select my key pair. If you don't have a key pair, you can go ahead and create a new key pair, but you need a key pair to connect to that instance. I'll go with the default security group. 8 GB is sufficient. T2.micro is what we are using, and then launch instance. So this will start launching the EC2 instance, and we'll be using this to run our Spring Boot application, and this is where we'll be installing the prerequisites as well. So let's wait for the instance to come up. Just waiting for the instance to come up. So here is my instance. Let me quickly do an SSH into this instance. So we'll do an SSH into the instance. So SSH -I, I'll specify my key pair, the username, and the IP address, and this should connect to the EC2 instance. Now, once you're connected to the instance, there are a few prerequisites that we will need. So I told you that this is what we'll be using. So we'll be using Spring Boot, Maven, and Docker. So we'll need to install these prerequisites. So for Spring Boot, we'll need Java. We'll need to install Maven, and then we'll also need to install your Docker. So let's go ahead and do this. So let me make this a little bigger so that you can see the commands that I'll be typing over here. So the first thing that we'll do here is we'll update the machine. So if there are any updates that needs to be applied to this machine, we will go ahead and update that. So this should apply all the available updates that are available for this Ubuntu EC2 instance. We'll wait for this to complete. Post this, we are first going to install our Java. So we'll use sudo apt install openjdk 17 jdk. So we are installing Java version 17. I'll tell you why we are using 17 in some time. And this should go ahead and install Java for me. Okay, so give it a few seconds and this should install Java for us. And once Java is installed, you can validate the version of your Java as well. So I'll show that as well. So let's wait for this to complete. Okay, so that should install Java for us. So you can validate your Java by running this Java hyphen version command. And there's my version 17 installed. So we have Java for the Spring Boot application. Next, we'll be installing Maven. Now we also need Java for your Maven as well. Now to install your Maven, we'll be running the sudo apt install Maven. Sudo apt install Maven. And this should install the Maven tool for us. So again, give it a few seconds and this should complete the installation of your Maven, and then you can validate the version as well. So for this, we can use mvn hyphen version, and that should tell you the version of Maven that we have installed, right? And the last thing we need is your Docker. So we'll use sudo apt install docker.io, and this should install Docker for us. And again, you can validate the version of your Docker by running the docker hyphen version command. So let's wait for this to complete. So this is completed, and then we can check docker hyphen version, and there's my Docker installed. Now your Docker, it follows your client server architecture, so just make sure the Docker service is in the running status. If it's not running, then you will need to start the Docker service. So we have all the prerequisites installed. We have our EC2 instance, and we have the necessary tools that we will need to run our application. The next thing that we are going to do here is we are going to generate our sample application. Now to generate the sample application, you can head over to this website, which is start dot sorry start.spring.io. Okay, so that would be your URL. I'll post this URL in the description section. You can get it from there, but that's the URL. So this is what we can use to generate our sample application. Okay, so project, this is going to be a Maven project. We're using Java language. This is the version that we want to use, and you can fill in your metadata. So let's say Docker, and let's call this as Spring App. We want a jar package, and this is the version 17 Java. That's why in the server I had installed version 17, if you recall, and then click on generate. Now what this will do is this will download a zip file to your local machine. So if you check in your local machine, you should be able to see a zip file. Okay, now this is what we will be using in our EC2 instance. Now my EC2 instance is running on AWS, and then I have the zip file on my local machine. Okay, we'll need to copy this over to our EC2 instance. So for this, we'll make use of the scp command, which is a secure copy. So scp -i will give the key pair, and then your source. So my source would be this zip file, and then the destination would be my EC2 instance. Let me grab the IP address and then the path.
So I want to store this in this path. Now if you see here, this would be empty. Okay, I don't have the zip file. So we'll go ahead and give the path and run this, and this should upload the zip file to the EC2 instance. Okay, so we are doing a copy. So if I go and check, I should be able to see the zip file. So we have our app now available in the EC2 instance. We'll unzip this. So most probably you may not have the zip command. So we are going to install this. So sudo apt install unzip, and we'll use this to unzip the package, the application package that we have. So let's do unzip and the file name, and this should unzip the package for us. So we have it over here. If you want, you can go ahead and delete this if you no longer need that, but I'm going to keep it there. No harm in that. And this should have everything for your application. So we have a pom.xml file because it's a Maven project, and this is where we will have your application code. Okay, so if you go to main and if I go to Java, we should be able to see the file here, which is your Spring app application.java. So if you read this, you should be able to see the application code. So this is basically what. So it's a sample application, like I said. So we have our code, we have the application. The next thing that we'll need to do is we'll need to update some of this code. So we'll need to first update this pom.xml file. So in the pom.xml file, one thing that we'll have to check is your dependency. So this is going to be a web application. So here in the artifact ID, make sure we are using spring-boot-starter-web. Okay, it's a dependency that we are creating. And the other thing that you may want to check would be, yeah, I think the pom.xml file, we just need to update this spring-boot-starter and just append this -web. That should take care of packaging the application. Then in the source, okay, so let me go over here, and so basically in the source, under main, under Java com example Docker Spring app, we will have our application code. Okay, so we will need to basically update this. So let me open this up. Now what do we need to update over here is, first we will need to add this couple of import instructions. So we are gonna update here a couple of import instructions. Then we are gonna have this REST controller included here, and then we are gonna have our call. So we are calling the request mapping here. Okay, so let me just indent this. So essentially, when I give a slash in my URL, it should return this, is essentially what I have mentioned over here. Okay, now if you want, you can update this whatever you want based on your requirement. For example, let me just remove the screen lines. So something like this, for example, so I can copy paste this again, but then I can change this to, let's say, if it is slash home, and this would be, let's call this as home page. And what do you want to return? So let's say we'll put a HTML code over here. Let's say this is the home page. Close that. Likewise, we'll update here as well. So let's say if I give slash login, so this would be my login function, and I want to return something else. And then finally, the last one would be slash logout, and we'll have a different function for this. Let's call this as logout, and I want it to return something else. Okay, so likewise, if you want to add more, you can definitely add, but in our case, this is what you're gonna use. So we'll save this. Okay, so we have the code ready. The next thing that we're gonna do here is we're gonna test this to check if the Spring Boot application is working as expected or not. So for this, we'll be using Maven. Okay, so we'll use this mv1, and then we'll use spring-boot run. So this will essentially try to run the application that we have in the source. Now, if you're running this command for the first time, this will download a whole bunch of things. Don't worry about this. All these are your Maven plugins that are getting downloaded, and it's a one-time task. The next time when you do it, all these plugins will be available on the local machine itself, and your Maven will try to use that plugins from the local machine itself. But since we're running for the first time, it will take some time. And here you should be able to see that my Spring Boot application has come up. Okay, so here you can see it has started my Tomcat server and started my Spring Boot application as well. Now, how do we access this application? Now, we know that we are running this on an EC2 instance, so we can take the EC2 instance IP address. But before we access this, we are running this on Tomcat. So Tomcat, it runs on port 8080. So make sure in your security group, you are allowing port 8080. If not, you won't be able to access the application. So we'll hit the IP colon 8080, and the slash, if you remember the code that we updated, if it is slash, it will go to this, and if I give slash home, it will take me to some other, it will return some other data, and if I give slash login, it will return some other data, and likewise if I give logout, it will return some other data. So basically the application is working as expected. So we have our sample application ready. Now to cancel this, you can use Control C, and it should basically come out of the application. So we have our application ready. The next thing that we'll need to do is we're gonna containerize this. So we'll be creating a custom image, a Docker image out of this, and then we'll be using that image to run our container. Now, before we do that, we'll need to generate the package. So as of now, we have not yet, or rather, we should have the, yeah, we don't have the package yet, right? So we'll go ahead and create a package. For this, we'll use mvn clean package. So clean would help us to delete this target folder. So basically clean up the old package and then create a new package for us. So we'll run this, and this will go ahead and create the target folder once again and create our jar package in this case. Okay, so let's wait for this to complete. Shouldn't take much time, and should be able to create the jar package for us. So again, this will create the target folder, but then this time we should be able to see the jar package created for us. So let's wait for this to complete, and this is done. So sorry. So there's my target folder, and inside the target folder, I should be able to see the package. So this is the package that we will be needing. Now that we have the package, we're going to create a Docker file for our case. Oh, sorry, there's a typo. So Docker file is basically what we use to create our custom images. So all the instructions that you want to pass to build your image, we make use of a Docker file for that. Now the instructions that we're going to use in this is over here. Okay, so let me explain this. So we are using OpenJDK 18. Remember the application, it needs minimum 17 to run the application. So we're using Java as our base image version 18. We are setting our work directory to /app. We are copying our package from a target folder. So this would be the package name to our image in the /app. We're exposing port 8080 because it's a Java application. So we want our container or Docker to listen on port 8080, and then we are basically running that jar package. So using the cmd command, we will be running the jar package so that our application will be up and running. Okay, so let me take this and put it in our Docker file. Now the only thing I need to verify is the name, if the name is correct or not. So let me do a target. So spring hyphen app hyphen 0.0.1 hyphen snapshot.jar, and in the Docker file I just need to make sure there's no mistake. Okay, so you can see here this is spring hyphen app, but whereas here it is having only spring. So I need to update this. So let me update this to spring hyphen app. I'll need to also update it here. Okay, so let's check this once again. So spring hyphen app hyphen 0.0.1 hyphen snapshot.jar. So that looks fine. So we have our Docker file ready. The next thing we will need to do is create an image out of it. So to create our image, we use the docker build command. So docker build, and we'll tag it. So this is going to be my spring app and then dot, which is to specify the Docker file. So we'll run this. Okay, so I'm getting a permission denied error. Okay, so let me try this with the sudo instruction. Okay, so this will start building the custom image. So I have in total, I have 5 instructions. So first is to get the base image. So this is downloading it from the Docker Hub. Then we have set our working directory. We have copied everything to the image we have exposed, and there is my command. And my image has been successfully built. You can check your image by running this docker images command. Oops, sorry, I need to use sudo for this. And here I have my image. Using this image, we will be starting a new container. So for this, we'll be using the docker run command. So docker run, you can use -dit in case you want to interact with the container, you want to connect to the container, and we are doing a port mapping. So let's do a port mapping of 80. You can use essentially any port mapping you want, but why do we need this port mapping? Now if you want to access your container over a browser, now we know that your container is an isolated process that we are running inside a machine, in this case an EC2 instance. Now we cannot directly hit the container. The container won't process our request, or it won't return the traffic. So we need to do a port mapping, which is the right hand side, the port number that you see, this is the port number that we have in the Docker file. Okay, and then this is what we'll be using on the browser. So when I hit this, my machine will in turn redirect the traffic. You can think of it as more of a proxy that we're doing here. I cannot directly access this if you're running it as a container. We'll need to always do a port mapping, and then we will give it a name. So let's call this as spring container, and then finally the image. So in our case, this is the image we have, and this should start a container for us. So you can check if your container is running or not by running this sudo docker ps command, and here is my container running. So you can see the container ID, that's my image that I'm using, what command was executed, when this was created, what is the status, what is the port mapping we have done, and what is the name of the container. Okay, now I can take the server IP and I can access this on port 80 directly because I have done the port mapping. And again, if you're not able to access this, make sure you have allowed port 80 in your security group. Okay, and now I'm able to access the application that we are running. in the container. So you can see I've not given any port, but because of the port mapping that we have done, I'm able to access the container. So this is the same application that I accessed here. So this was a standalone application that I ran directly on my machine, but whereas this one is a containerized version of the same Spring Boot application. So once again, what I did was we have created our sample application. We got that over to my EC2 instance, and then we have updated the pom.xml file as well as your Java code, the source code. Then we ran this application as a standalone by running mvn spring-boot :run and validated the application. Post that, we created a Docker file. We gave our custom instructions. We created an image, and that from that image we are running a container. So this is basically how we can Dockerize a Spring Boot application and then run that application as a container. Now, you can either choose to generate the application. If not, I also have this project stored in my Docker Hub account over here. This is still, I'm updating it, but you should be able to see the Docker file over here, the same instructions that we have used. And also you should be able to see the updated pom.xml file. So this is what I was talking about. Okay, line number 22. Okay, and also in the source under main, under Java application or Java, few changes. One is including these import statements, having this REST controller, and then updating your return statements, whatever you want to return based on the path that you want. So you can directly use this as well. I'll provide the link to this project in the description section, so you can refer this as well. Don't forget to don't forget to follow my GitHub account as well. So that brings us to the end of our first project on Dockerizing a Spring Boot application. I hope you found this video helpful. If yes, leave it a thumbs up. Don't forget to subscribe to the channel and hit that bell icon for notifications. If you have any other specific requirements, please post them in the comments section. And thank you so much for watching this video. I will see you in the next one.